Unit 1, The Alphabet and Grammar of Geometry. Lesson 1.4, Geometry Grammar, Part 2, Logic Rules. Don't forget the date, time, location, and a parent or guardian sign-off. Students, keep in mind that focused attention equals faster work. Please do not attempt to multitask while you're watching this video. This is your review page. I'd like you to pause the video, do this review page, and then restart. Pause the video. Welcome back. Let's see how you did here. It says right here is if you sing daily, this would be your cause. Then you will have a happy heart. This is the effect. Sing daily, happy heart. Converse, you switch. So it would be if you have a happy heart. I'm just going to do ... because we're just correcting. Then you sang daily. That would be the switch. Then. And the opposite, inverse, is if you are not singing daily, not sing daily, then you don't have a happy heart. No happy. I'm just going to leave it there since we're running out of space. And then a contrapositive, you switch and negate. So if no happy heart, then not singing daily. Okay, converse, switch, inverse, flip, contrapositive, switch, and flip. Here you solve for R, you physically cross multiply, so your next line should read 5 times 7 equals, and 3 parentheses R plus 7. 35, this is 3 R, we circle and distribute, plus 21, so we're minusing 21. Yes, it is a fraction, folks. For those of you who thought you were wrong simply because it's a fraction, fractions are not wrong. Okay, so there's your quick review, both an algebra review and your first logic rule, which was conditionals. Today we're going to continue studying logic and reasoning. First, we're going to talk about 2 different kinds of logic, inductive and deductive reasoning. Then we're going to talk about 3 different laws. Law of Syllogism, Law of Detachment, Law of Contrapositive, and then a concept called conjunction and disjunction. Make sure you have some colors handy. You might find it helpful. Just take a look at all these pictures and ask yourself, what do they all have in common? There's a couple things you can notice that they have in common. One, of course, with the golfing club, they are all golfers. Another thing you noticed, or maybe you did, is that the golfers, they're all wearing some sort of hat. Okay, you could also notice that they're also, all of them are outside. Okay, so just making some observations about golfers. And says, what piece of clothing do you notice in each and every photo, not video. And you should have noticed that in all the photos, every single golfer is wearing a hat of some sort. Okay. Now, making these observations, and then I come to a general conclusion. Imagine you knew absolutely nothing about professional golf attire. To learn more, you decide to attend all professional golf matches in a year, and you observe very closely each golfer's outfit. After observing hundreds of professional golfers on the course, you conclude, underline the word observing, and conclude that if someone is a professional golfer, he or she always wears a hat on the course. Therefore, you come to the general conclusion that all golfers wear hats on the course. You come to a general conclusion. This type of reasoning is called inductive reasoning. Inductive reasoning. You make observations and you come to a generalized conclusion about all golfers. That's called inductive reasoning. So right here, there's a difference between inductive and deductive. Inductive and deductive. Inductive reasoning, you take in information. We have multiple observations. You take in multiple observations and you come to a general truth. That's called inductive reasoning. Inductive. So you take in observations and come to a general truth. An aha moment. Aha, I've discovered all golfers wear hats. Deductive reasoning says I take that general truth and I apply it to a specific situation. That's why the finger's pointing. You're applying it to a specific situation. That's deductive reasoning. Okay, so in one instance, you're discovering truth. And another instance, you're using truth. In one instance, you're discovering truth. In the other instance, you're applying truth. Let me give you an example of deductive reasoning based on the whole golfer thing. Now, back to the golf example. After multiple observations, you come to the conclusion that all professional golfers wear hats on the competitive course. That's your general truth. Let's say you met a Mr. Tin Vu at a restaurant, and he tells you that he's a professional golfer. He's sitting in a restaurant in a full suit and a tie. It must be a fancy restaurant, so he's not wearing a hat. You ask yourself, but what assumption can you make about his choice of clothing while he's on the golfing green? You can make a truth application based on your general truth. What could you assume to be true about Mr. Tin Vu if he's a golfer and his choice of clothing when he's on the golfer green? I'd like you to fill that sentence out yourself. I'm not going to do it for you. So in inductive reasoning, you discover a general truth. The general truth was, after many observations, you come to the conclusion, aha, if you're a golfer, you're going to wear hats when you're on the golf course. You apply the general truth. Mr. Tin Vu at that moment is not wearing a hat because he's in a full suit and tie at a fancy restaurant. But if he says he's a golfer, you can apply the truth and know that he most likely wears hats when he is on the golf course. Even at that moment, he's not wearing a hat. That was an attempt at a hat, and that did not work very well. Sorry, you artist folks, that was a horrible hat attempt. Taking a look here. So what I'd like you to do is I'd like you to read these two examples, underline the key words, and determine, is it inductive or deductive? Do this on your own, and then restart the video. Pause. Welcome back. Did you actually do this yourself, folks? Really important you did it by yourself. Okay, keywords. You know that all Olympic athletes must win at the national level prior to competing in the international Olympic competition. The key word there is know. You are starting with a truth. You are starting with a truth. Gabby Douglas competes in 2006 Olympics, 16 Olympics. Therefore, you conclude she must have won at the U.S. Gymnastic National Championships. That would be deductive. You take a known truth and you're applying it to a specific person and making a conclusion about her specific sporting experiences. That is deductive reasoning. You are testing the hypothesis that the rate of falling of an item does not change depending on the mass. From the same height, you conduct hundreds of experiences, dropping items of different mass at the same time. Both items hit the ground at the same time. You conclude that items fall at the same rate regardless of mass. Here, you're discovering a truth. And that would be inductive reasoning. First one was deductive. Second was inductive. Okay, there's 3 more logic laws. Now, these logic laws will sound super fancy, but I promise you, you are surrounded by these already. Okay, the law of contrapositive, the law of detachment, and the law of syllogism. The law of the contrapositive says this. I'll give you the symbols first. If, put quotes here, P then Q is true, then opposite Q, opposite P is true. The switch and flip. I'll give you the symbols first. If P then Q is true, then opposite Q and opposite P is also true. Right now, that's just a bunch of letters. Just write it down. If P then Q is true, then opposite Q to opposite P is true. Okay. Here's the actual explanation. It says, if you drive a Mini, then you drive a car. That is a true statement. If you drive a Mini, then you drive a car. Contrapositive is this. If you don't drive a car, then you don't drive a Mini, which is a true statement as well. So this law says, the law of contrapositive says, if the original conditional is true, then only the contrapositive is forced to be true. Inverse and converse, again, are maybes. We did that last class, so that's not new information. That's a law you learned last time. That's the law of contrapositive. Now here's 2 other laws. You honestly already know these. I'm just putting fancy names to them. First one's called the Law of Detachment. It's from generalization to a specific. Let's do the symbols first. If Okay, a lot of stuff there. Let me spell it out. It says, if you have a general, if P then Q is true. You have a general conditional, that's true. And you can detach the P and Q. If P is true, then Q is true specifically. Just write the word specific there. This won't make sense until I give you an example. It's okay if you don't understand. If P then Q is true and P alone is true, Q alone is true. If P then Q is true and P alone is true, Q alone is true. Looks like this. You have a general conditional. It's kind of like the golf hat example. If you own a car, then you can drive yourself to work. This is an if P, then Q is true, and that is a true statement. Now, we say a specific P is true. If Aman owns a car, if that alone is true, he does actually own a car, then Aman can drive himself to work. We detached the P from the Q. So once again, if the general P then Q statement is true, if the general conditional is true, and a specific first part is true, generally you own a car, Aman owns a car, then the second part specifically must be true. Generally you can drive yourself to work, Aman can drive himself to work. Law of detachment, you can detach P from Q. Generalization to specific. Syllogism. You get this all the time from parents and coaches and teachers. Trust me, you get this all the time. Go something like this. Ready? Say if P and Q is true. And Q then R. That's a cursive R. I know a lot of you can't read a cursive R, so I'll do just an italics R. R is true. If P to Q is true and Q to R is true, notice we're connecting. Therefore, these three little dots mean therefore. You'll catch that a lot in physics and chemistry. Therefore, if P then R is true. If P then Q is true and Q then R is true. You get this all the time. Let me give you an example. If you get a job, then you can earn money. If you get a job, then you can earn money. If you earn money, then you can purchase a car. Therefore, if you get a job, then you can purchase a car. That is called the Law of Syllogism. Law of Syllogism. Alrighty. Ready? We're going to do one together. We're going to write out the logical conclusions of this statement. And we're going to write out the logic laws that it demonstrates. Okay? Here we go. First we read. Underline your keywords. If you practice math daily, your math skills will improve. If your math skills improve, then you will do well on math tests. Notice the repetition here. Math skills improve, math skills improve. That's like if P, then R, then Q, and if Q, then R. Therefore, you can connect P to R. Notice the repetition there. So I can write, if you practice math daily, then you will do well on tests. Okay, the logic law we used for that allows you to make that conclusion, is the Law of Syllogism. Law of Syllogism. If the first is connected to a second and second is connected to a third, the first and third are connected. That's called the Law of Syllogism. Let's try another one together. We're going to do two more. Okay, so here, if you learn a new language, then you will have more interconnected neurons. If you have more interconnected neurons, then you are smarter. Notice the repetition. Interconnected neurons, more connected neurons. This is going to be the law of syllogism as well. If P, then Q. There's the repetition. If Q, then R. Therefore, you can connect P to R. So right here, it says, if you learn a new language, then you're smarter because you have more interconnected neurons. Let me keep the color coding straight here. I used green for that. Then you're smarter. Okay, that was the law of syllogism. Okay, this one says, if someone is in a medical course, then they took a full year of anatomy and physiology in college. Monica is a medical doctor. Okay, notice kind of the repetition. If someone is a medical doctor, Monica is a medical doctor, then they took a full year of anatomy and physiology in college. Then what can we conclude about Monica? Okay. According to our rule, if someone's a medical doctor, generally they took a full year of AMP in college. Monica is a medical doctor. Therefore, this is what we can conclude. Monica took a full year of anatomy and physiology. At the college level, we call that AMP. In college. That law, if P then Q, this is if P then Q is true, P alone is true, therefore Q alone is true. That's called the law of detachment. Logic law of detachment. Ready? This page, you get to do all by yourself. Get a red pen when you're done. Pause the video. Welcome back. Okay, a couple things we can do here. It says, if you're a Valley Theater major, then you must participate in at least one Valley Theater production. Marquis is a Valley, let me keep my color straight here. Marquis is a Valley Theater major. Therefore, what could you conclude? You conclude that Marquis will participate in at least one Valley Christian Theater production. What allows me to say that? It's law of detachment. You go from general to specific. Law of detachment. If you pray daily, then you will connect with God's love consistently. If you connect with God's love, then it will be easier to love others. So you see that repetition there of connecting with God's love. So that's if P, then this will be Q. If Q, then R, and we can connect P to R, which is syllogism, which looks something like this. If you pray daily, then it will be easier to love others. That is the law of syllogism. All right, students, I recommend you just take 2 minutes, verbally recap to yourself what happened page by page, even less than 2 minutes. But by verbally just flipping through the pages and doing a quick little recap, it'll help move that memory from short-term to long-term storage.